Welcome to Code Jumper. This lesson is about decomposition. The objectives of this lesson are that students will identify a complex problem that'll be easier to solve by breaking it down into smaller problems. Students will understand that one method for solving a complex problem is to break it down into smaller problems, making it easier to solve. The expected outcomes are that all students will be able to identify a complex problem that will need to be broken down into smaller problems to solve it. Most students will be able to break down a complex problem into smaller parts to make it easier to solve. And some students will be able to break down a complex problem that is made up of 3 or more parts. A key vocabulary word for this lesson is decomposition. Decomposition is a key strategy within computer programming where you need to break down a complex problem into smaller parts in order to make it easier to manage, understand, and solve. The first part of this lesson is an unplugged activity. The objective is to introduce students to the key strategy for completing a more complex task by breaking it down into smaller tasks. The materials needed for this unplugged activity are a cardboard box or some type of box with rocks in the classroom. You'll also need an empty box, maybe in the hallway or somewhere a little further away from the first box. You'll need rocks or objects of some kind that have at least enough of them that each can, there's enough one for each student. At least one rock, or this estimates the size of a baseball, but use what you have around you to make it easy. And a timer, and students will need their computer science journal. So, in the beginning of this lesson, place the box with the rocks in it somewhere where students can access it easily, and put the empty box maybe out in the hallway. Students are going to gather around the box of rocks that are in the classroom, ensuring that the box is somewhat in the center of all the students. Tell them that their job today is to figure out the fastest and most efficient way to empty all of the rocks from the box in the classroom into the box in the hallway. But there are a couple of rules. Each student can only take one rock. They can only hold one rock at a time, all walking, no running, and you can hand a rock to another student, so it doesn't have to be one rock per student and then they stay with that one. They can hand it off. If a rock falls on the floor, it has to go back into the big box and they have to start their turn again. So students are going to come up with an initial strategy at first, and they're going to try and carry out their plan, getting getting rocks from one box to the other. If students have a visual impairment, you might try adding a string from the box of the rocks to the other empty box that students can follow. You could also have some students be spotters along the way. Students can give each other clear directions about where to meet the next person, like walk 2 steps forward or 3 steps to the right, etc. Set a timer and let students give it a try. Then, after the timer goes off, have a debriefing discussion about what strategies worked, what pieces of this big job were able to be broken down into smaller jobs. Discuss which one worked better than another. Then, as an entire group, come up with a different strategy and try it again. I would try this a couple different times to help students recognize that there are smaller portions of this big job and there's lots of different strategies that could be tried. In computer programming, decomposition is a key strategy for trying to solve a problem. It helps break down those complex problems and make them a little more manageable. And what students are doing when they're discussing and debriefing this rocks issue is they're actually breaking it down and using the strategy of decomposition to identify different parts of how to solve this bigger problem. Taking one rock or a few rocks at a time is a lot easier than carrying that giant heavy box of rocks. In the guided activity, Students will break down programs into smaller, more manageable pieces. They'll still be using the word decomposition as a vocabulary word. The materials needed for this section are the Decomposition Guided Activity Melody and Rhythm 1 code card, as well as the Melody and Rhythm 2 code card, and their computer science journal. So in this guided activity, up on the screen right now, I have some information for you, but students are not going to be able to see this. Up on the screen on the left is thread 1, piano, and thread 2, percussion, and some lines of code underneath. And then over on the lower right corner is an image of Code Jumper all put together in the same way. And I'm going to run through that in more detail in just a moment. But first, I want you to kind of experience what students are going to experience. You're going to have this all set up ahead of time, and you're going to let students listen and try to hear what's happening in this program. So I'm going to push play, and you're going to just imagine what I have and imagine how this program might be built and try to think about the possibilities just by listening to the sounds. So I'm just going to press the play button. Oh, that is difficult to hear what's going on. Students are probably going to need to listen to this a couple of times to see if they can decompose or figure out the parts that make up this program. So ask students maybe what kinds of things they can do to help break down this program, to identify what are the pieces, what are the lines of code in this program. Now, the answers for you right now are up on the screen, but the goal is for students to identify their strategy for decomposing. They might suggest to take out thread 1 or just listen to it again and focus on listening to what they think might be thread 1. They might ask to take out one of the threads from the hub and just listen to one thread at a time. In their computer science journals, as they're doing this, have them write down what they predict are the lines of code for each of those threads and see if they can get close to at least decomposing or finding some of the smaller pieces of this larger program. Once students have figured out both threads and they have it in their computer science journals, ask them to work in groups to recreate the program. They should recreate the program with Code Jumper and then compare it to your program. Then play the sample program from the Melody and Rhythm 2 code card and ask students how they're going to solve this problem. They're going to work in their groups to try to recreate it, and this might be a little bit more chaotic because it's a little less guided, and students in their groups are going to try all of the strategies that they may have heard the first time that they went through this activity. The exploration activity takes it to one next step of independence. The objective of this is that students will explore decomposing, taking apart programs that have been created by their peers, and record their observations in the computer science journal. They'll need a Code Jumper kit as a material and the computer science journal. Each group will put together a program with 6 play pods, a loop, and they're going to be required to use 2 threads. The groups of students will then create a program in their computer science journal and in Code Jumper, just any kind of program they want using those requirements of 6 pods, a loop, and 2 threads. Once it has been created and debugged and you're sure it matches the code that they have written down, they're going to play it for another group, and the other group is going to have to decompose it. One strategy could be to put a piece of paper or cloth over the pods so that only the hub is visible and could be listened to. As long as they can't actually see the app or the Code Jumper that is put together, but they have the opportunity to press the play button and hear what it is. They're probably going to need to hear it over and over again to be able to decompose it properly. They'll listen to the other group's program and try and write it down in their computer science journal. Then, when the groups have finished, they'll compare to see if they have correctly decomposed the program. And that is it for decomposition.